Okay, so now let us start with a simple problem. You can see a 4-meter ladder weighing 200 Newton is placed against a vertical wall as shown in the figure. As a man weighing 800 Newton reaches a point 2.7 meter from point A, the ladder is about to slip. Assuming the coefficient of friction between ladder and wall is 0.2, determine coefficient of friction between ladder and floor. Okay, so this is a given figure. Point A, point B. Total length of the ladder is 4 meters. So we all know that the weight of the ladder will be acting exactly at the center of the ladder. So the center is 2 meters. So at 2 meter, 200 Newton is acting. In the question it is mentioned that as a man weighing 800 Newton reaches a point 2.7 meter from point A. So from here, totally from here 2.7, 2 plus 0.7 is 2.7. So from 2.7, a weight of 800 Newton or a man is standing here. So 800 Newton, the ladder is about to slip. Okay, so coefficient of friction, what is that clear? Assuming coefficient of friction between ladder and wall. So here mu b, that is coefficient of friction between ladder and wall, is given as 0.2. We need to find coefficient of friction between ladder and floor. Ladder and floor. Okay, so now let us draw a free body diagram first. So see here, let this be our, I am drawing the same thing here. So this the same free body diagram I am drawing here. So now this is a ladder. So first we will draw a ladder here. Say this is a ladder. Okay. Now as a person is climbing here, there is a possibility of this ladder moving backwards here and downwards here. So frictional force obviously acts in the opposite direction. So first we'll call this as FA. Okay, because motion here in this direction and motion here in the normal direction. Okay, so frictional force here and frictional force will call this as FA and FB. The same thing I am redrawing there because this is a standard free body diagram for every ladder friction. Okay, now there is a perfectly vertical contact surface, that is a perfectly vertical wall. So there is a perfectly vertical normal reaction. So here NB and here NA, because we know that normal reaction will be acting perpendicular to the contact surface. So here this is perfectly horizontal contact surface, so perfectly vertical normal reaction. Similarly here. Now angle is given as 60 degree here. So first we'll draw angle as 60 degree. So at 2 meter 200 Newton is acting. So at 2 meter 200 Newton is acting. So this is 2 meter. So at 2.7 meter, okay, so at 2.7 meter, 2 plus 0.7, 2.7, 1 second. Okay, so from point A, so this is point A, this is point B. So from point A, totally at a distance of 2.7 meter, 800 Newton load is acting. So from here the distance is 2.7 meter. Okay, so here the weight of 800 Newton is acting. Total length is 4 meters, right? Total length is 4 meters. Okay, now mu A is given as, sorry, here mu B is given, right? Sorry, so mu B is given as 0.2. we need to find mu A, that is coefficient of friction between ladder and floor. Okay, so first we'll use the condition. What I have told you, we have to use the three conditions: summation H equal to 0, summation V equal to 0, and moment about any point equal to 0. So first, summation of horizontal forces is equal to 0. So you can see here FA is acting along FA is acting along positive x-axis, so we'll write plus FA, and NB is acting along negative x-axis, so minus NB is equal to 0. So that implies FA is equal to NB. We'll call this as equation number 1. Second condition, summation of vertical forces is equal to 0. So summation of vertical forces is, you can see here NA acting vertically upwards, right? FB acting vertically upwards. So NA plus FB, right? So 200 acting vertical downwards, 800 acting vertical downwards, minus 200 minus 800 is equal to 0. That implies NA plus FB is equal to 1000. We'll call this as equation number 2. Right. Third condition, summation of moment about any point equal to 0. I will consider moment about point A. Okay. So first we'll consider 200 Newton force. Okay. So force into perpendicular distance. So this is 200. So first I will write 200. This is force. Sorry, 200. This is force into perpendicular distance. So here the force is vertical. We need a horizontal distance. So this is a force. Now we need distance from here to here. Distance from here to here. If this is 2, this is 60. That means this is 2 cos 60 and vertical component is 2 sin 60. Right? Can you imagine? So here this is 2 meters. Right? The angle here is 60 degree. That means if you resolve this from here to here, this is 2 cos 60. Correct? And here to here this is 2 sin 60. Right? So again we want, this is the force 200. We want this distance. This is 2 means this is 2 cos 60. So 200 into 2 cos 60. This is force. This is perpendicular distance. This is force. This is perpendicular distance. Okay. Now we'll see whether it is a clockwise or anti-clockwise. So you can see here this is a clockwise effect. So I'll write plus. Similarly, I will choose 800 now. Again this is a clockwise. So I will write plus 800 is a force into again perpendicular distance. Now again distance is 2.7. We want this distance. So 2.7 cos 60. So 800 into 2.7 cos 60. Right. Now I will consider FB force. So FB, sorry, I will write FB here. This is force into, now we have to write perpendicular distance. So here this is FB. Okay. If you, we want this distance. So this is 4. Okay. We want this distance. This is 4 meter. We want this distance. That means this is angle is 60 here. So this is 4 cos 60 and here it is 4 sin 60. So FB, this is FB into 4 cos 60. FB into 4 cos 60. Now this is clockwise or anti-clockwise. You can see this is anti-clockwise. So I will write minus here. I will consider NB. So I will write NB here first. So NB into force, this is 4 into perpendicular distance again. So again this is 4 meter. If you see here, this is the NB force is going like this. You want this distance. Again this is 4, this is 60, this is 4 cos 60 and this is 4 sin 60. So this is NB into 4 sin 60. Now this is clockwise or anti-clockwise? It is anti-clockwise. So minus NB into 4 sin 60 and that's equal to 0. If you solve this equation, you will get, NB as 331.60 and we know that NB is equal to what? NB is equal to FA. So FA is equal to 331.60. Right? Now NA is equal to what? NA is equal to 1000 minus FB. So NA is equal to 1000 minus FB. FB is equal to what? Mu B into NB. So mu B into NB. So NA is equal to 1000 minus mu B. We know that it is 0.2. NB we got the value as 331. So if you solve this, you will get the value of NA as 933.68. 933.68. Okay. So now we want to find coefficient of mu A. So we know that coefficient of friction FA is equal to mu A is equal to FA divided by NA. So FA is equal to what? FA we got the value as 331.60. So this is 331.60 divided by NA. NA we got it as 933. So mu A is 0.35. NA is 0.35. So this completes a problem.